Hello everyone. Today let's solve the problem number 207, course schedule. Right. So what the question states here, we are given an num courses here. You can clearly see we are given num courses labeled from 0 to num course minus 1. Right. So this one we have to keep in mind. We have given a num courses labeled from 0 to num courses minus 1. 0 to num courses minus 1 and a list of prerequisites where each pair a comma b here, this one you can clearly see list of this one list of prerequisites where each pair a comma b means that to take course A we must finish first we have to complete or finish course B, right? So we need to determine if it's possible to finish all the courses. So here accordingly with the question, to complete one here course 1 we need to complete course 0 first. So here in the example 2 they have given prerequisites. To complete 1 we need to complete 0. To complete 0 we need to complete 1 first accordingly with the question they have given. Indirectly what they are saying, if it forms a this one cycle, then we have to display false or then we have to return false, right? So if it doesn't form a cycle, if we can complete all the courses, then we have to display or return true, boolean value true in that case. So that's what the question says here. So I hope the question is completely clear here, right? So I hope the question is clear. Let's come to the example here. So they have given num courses 2 and prerequisites they have given 1 here, 1 comma 0, right? So we know that to complete 1 we have to complete 0 first. So this we can consider in the form of directed graph here. So first what we will do, let's consider here 0 and this one pointing towards 1 here, right? Here why we have considered 0 first here pointing to 1, because to complete 1 we need to complete 0 first, right? So that is why we have considered this one, or we can visualize this one in the form of directed graph. I hope this is clear. In this one 0 comma 1 we can consider, right? So here to complete this one we have to finish first 0, right? So this can be done. Here cycle is not found, so we have to display in this case true, right? So for the second example, to complete 0 we have to complete 1, and to complete 1 we have to complete 0 here. Same thing, this one further if we do the same steps, it forms a cycle here, right? So this cannot be this is not possible. In this case we have to return false. This one will be true and this one will be false. So that's what they have given. So I hope the question is completely clear. Let's discuss the approach first initially, and followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written, right? Initially let's discuss the approach. So let's discuss the approach step by step. I have considered the same example, the first example that they have given in the question. So what we need to remember here, we are going with the topological sort using the Khan's algorithm, right? So we'll be making use of the topological sort with BFS using Khan's algorithm. So first thing we have to keep in mind here is we can visualize this problem as the directed graph that we saw, that I showed for the same thing while explaining the two examples that they have mentioned in the question, right? So we can visualize this problem as directed graph where each course is node and prerequisite relationship where each course is node and prerequisites. So I'll just give here prerequisites. A comma B, in the form of A comma B they have given, right? Prerequisites relationship A comma B forms a directed graph B of A. Why this forms a directed graph B of A? Because here to complete A we need to complete first B. So we can represent this one in this way, right? So it forms a directed edge from B to A. What is our main goal then? Our main goal is to determine if the directed graph has a cycle or not. If directed graph has a cycle or not. That itself we have to determine here. Right? So this is just I'm explaining. I'll just delete this one. Yeah. That's what we have to determine. So to detect a cycle, to detect a cycle, we will be making use of Khan's algorithm. Nothing but topological sorting using BFS. I hope this is clear, right? So just give me a second here. So yeah, let's see this one. Let's consider the first example here. I have considered first example that they have given in the question, right? So first step here is we have the courses, nothing but this one, let me give here step 1. So we have the courses here 0, 1. We have the prerequisites 1, 0, right? So two courses we have, nothing but 0, 1. Prerequisites they have given here 1, 0. I'll just write P here. Prerequisites they have given in the question 1, 0. Means we can represent this one in this way. Directed from 0 to 1, right? So graph, simple terms we can represent in this way, because to complete first 1 we have to complete 0. To complete 1 first we have to complete 0. So we are representing in this way. So adjacency list representation will be in this way, right? So what will be the in degree here? In degree array. So 0 has no prerequisites at all. Here you can clearly see in degree is nothing but arrow pointing towards 0 from any node. So we have only two nodes here. Arrow is not pointing towards 0 at all. So the in degree of 0 will be in this case 0. And what about 1? Here in degree arrow is pointing towards 1 here. You can clearly see. So the in degree will be 1 from in degree is pointing towards 1 from the 0th node, right? So here for 1 the in degree will be 1 in this case. I hope this is clear. This is the first step. So let's move on with the second step here. So we will be initializing q in this case, right? So this is nothing but in degree here. In this case, whatever we have written, this is in degree and this is adjacency list here, right? So this is prerequisites they have given and this is courses 0 and 1. Two courses we have right here. I'll just represent this one in brackets so that it will be easy to understand. So second step is we will initialize q here. In this case, we will initialize q. So when I say initialize q, we are adding the courses with in degree equals 0 to the q. In degree equals 0, this one 0 is having an in degree of 0, right? So first we are adding courses with in degree equals 0 to the q. So here what we are doing, we are adding course with in degree 0 to q here in this case, right? We are adding a course with in degree 0 to the q. Now q will be in this case it consists of 0. 0 is 0 node here 0 is having in degree of 0, right? So we'll be adding 0 in this case indirectly, right? So let's move on with the step 3. This was the step 2. Let's move on with the step 3. We will process the courses in queue. We have to process courses in queue. Let's see how we process the courses in queue. First, what we will do, we will take 0. We have 0 and 1. We will take 0. We will pop 0 from queue. Then reduce 1's in degree. Then reduce 1's in degree 1 to 0. Yeah, this is what we'll do. And add 1 to this one, 1 to q. So we will take 0 first. As we have 0 in q, we will pop will take 0, pop it from the queue, reduce 1's degree, nothing but 1 to 0. This is what I have shown here, and add 1 to the queue. We'll be adding this 1 to the queue. This is first step, right? And the second step here is we will take 1 next. So we have added 1 to the queue here. So we will take 1 now, pop this one, pop 1 from the queue. So now we have no more dependencies. We have 0, we had 0 and 1. After we took 0, reduced this one, pop 0 from the queue, then reduce 1's in degree, nothing but 1 to 0, and we have added 1 to the queue. Now 0 we have already popped. We have considered and popped the 0. And 1. Now we will consider 1. After considering 1, we will pop 1 from the queue. So no more dependencies here. No more dependencies left in this case. So we have considered the 2 steps here, right? So this is what we'll be doing in the step 3, right? Let's move on with the step 4 here. I hope the step 3 is completely clear. That is very important basically. So we'll check for the completion. We have completed 2 courses. So we have completed 2 courses here. In the previous step, you can clearly see here, we have considered 1, reduced the 1's in degree to here, you can clearly see 1 0. So next we'll be adding 1 to the queue. This is first course. And as we have added 1 to the queue, we will pop 1, and after popping 1, there is no more dependencies left. This is second course, right? So we have completed 2 courses, so which is equal to the num courses they have mentioned here. You can clearly see in the example, num courses they have mentioned here as 2, right? So we have completed 2 courses, which is equivalent to num courses. So in this case, we will return output as true. This satisfies all the condition. So in this case, we will return output as true, right? I hope this is completely clear. Similarly, you can check for the example 2 as well. This is how we can visualize, right? I hope the approach is completely clear. So next what we will do, let's discuss the edge cases one by one. So I hope the approach is completely clear, right? Please do try it out for the example 2 as well. We can visualize in the same way that I had showed for the example 1, right? Step by step, right? Please do try it out for the example 2. That forms a cycle there. So we cannot, we have to return false in that case. If you consider the example 2, we have to return false, right? So let's discuss the edge cases one by one for this problem. The first edge case that I'll be going with here is this one, simple valid case. So let me give here simple valid case in this case. So num courses, I'll just consider NC here. Number of courses, I'll consider 3 here. Prerequisites, I'll just consider P here. Prerequisites, let me consider 1, 0 and 2, 1 here. This is fine. Output will be true in this case. So why output here is true? You can just visualize in the same way. If you want to know all the steps, you can just visualize in the same way that I had showed for example 1. So here linear dependency we have. So no cycle is formed. In this case, we have to return true. This is for the first edge case. Let's move on with the second edge case. Nothing but cycle exists. So let me consider the same example that they have given in the question, second example, right? So num courses, I'll just consider here number of courses 3, and prerequisites, let me consider here 1, 0 and 0, 1 here. So output will be false in this case, right? So output will be false in this case because cycle exists. So direct cycle prevents the completion here. So here, yeah, this is for the condition cycle exists. So let's move on with the third edge case. Third edge case, nothing but no prerequisites here. No prerequisites here. This is fine. No prerequisites. Number of courses I'll just consider here 4, and prerequisites, no prerequisites, right? Condition. So here I'll just take empty array. So output will be true here in this case because no constraints at all. All courses can be taken freely in this case. So the output we have to return here is true. Let's move on with the fourth edge case or the final edge case. Or sorry, not the final edge case, fourth edge case, multiple independent chains. So I'll just give here multiple independent chains here. So when I say multiple independent chains, number of courses I'll just consider here 5. Prerequisites I'll just consider here 1, 0 and 3, 2 here. I hope this is clear. So the output will be true in this case. Again, I'm telling you can visualize or you can just try it out in the same way that I had showed for example 1 during the approach. Right? So you'll understand that one clearly. So here this is we have two independent sequence here. 1, 0, 2, 3 means 0, 1, 2, 3, right? We have. So two independent sequences we have. No cycle is formed. We have to return true in this case. Right? This is for the fourth edge case. Let's move on with the final or the fifth edge case. All courses interlinked. So I'll just give here all courses interlinked. Interlinked means cycle. Here it will form a cycle when all courses are interlinked. Here number of courses, let me consider 4. Prerequisites, let me consider here 0, 1, 1, 2. This has to be interlinked, right? 2, 3 and 3, 0. All the courses are interlinked here. You can clearly see 0, 1 we have given here. 1 we have here. 1, 2 we have given here. 2 we have here. 2, 3 we have given here. 3 is here. So all the courses are interlinked here. So we have, in this case, cycle is formed and we have to return false when cycle is formed. So cyclic dependency prevents the completion. We have to return the false in this case. Right? I hope all the edge cases that we considered is completely so just give me a second here. So, sorry, these are the edge cases that we considered. I hope this is completely clear. The first one that we considered is for the simple valid case. Second one we considered for cycle exists, for the condition cycle exists. So, third one we considered for no prerequisites. And fourth one we considered for multiple independent chains. And the last one or the fifth one we considered for all courses interlinked. Right? I hope this is completely clear. All the edge cases are clear. Now, let's start writing the code. So let's start writing the code. So we have discussed this one. We have to create the adjacency list first, nothing but the graph representation. For that one, I'll just consider variable name graph. We have to create the adjacency list, right? I'll just consider here array from. So initially within this, let me consider length of the courses, number of courses they have given. So number of courses here. This is fine. The other one is pointing to the empty array. So I hope this is clear, right? So second one, what we'll do, let's consider in degree here along with the graph. We need in degree as well, right? First, what we are doing, we are creating the adjacency list and we have to create the in degree array as well. Why adjacency list for the graph representation? So suppose if we have the prerequisites 1, 0 here, this one we have to create adjacency list for this, right? Because we have to complete 0 first to complete the 1 here. That should be represented in the form of adjacency list. For this one, line number 2, we have articulated that one in the form of code. And also we have to create in degree array. We saw that one in the step 2, I guess, while explaining the approach, right? We are creating an in degree array because we have to track incoming edges for each node in the prerequisites, right? We saw that one. I hope this is clear. In degree, what I'll do, I'll just come here. Let me give new. I'll just consider unsigned integer array, right? 16-bit array. So unsigned integer 16-bit array I'll just consider here. Of this one, let me pass here number of courses. This is fine. So the next step here is we have to build the graph and in degree array from prerequisites. So this we saw. We have to build the graph and in degree array from prerequisites. So for that one, I'll just make use of simple for loop here. This one for let what we are building here in degree graph and we have to build graph and in degree array, right? For prerequisites, I'll just consider in this case course and pre of prerequisites. So I'll just copy the same thing. I don't want to type this one again and again. Just give me a second here. Prerequisites. This is fine. So here pre is nothing but the course. This one in this way. So I'll just show this one first. Then let me write pre pointing to the course. So this one we have directed it, right? So I showed that one 0 pointing to 1 in the example. So how can we write that one? Graph pre here dot. So we have to push or we have to add or push course here. So we have considered course within the for loop. This one individual course, right? Course. So this is fine. Next step is we have to increment the in degree for dependent course, right? So here this is simple. In degree course, let's increment this one. We are just incrementing in degree for dependent course. I hope this is clear. Now yeah, we are done with building the graph and in degree array from the prerequisites. Next step is we have to initialize the queue with courses having in degree 0. So when we do not have the prerequisites at all, empty array, we saw this one in edge case if you remember, right? So we saw this one in the edge case. Again, I'm telling we are initializing queue with the courses having in degree equals 0. So this we can articulate in the form of code in this way. So I'll just give here in degree dot reduce. I'll just make use of the reduce q b I. So this one let me give here b or q dot push of I iterated value, right? So I comma q we have considered. Yeah, q v and I, right? So here q and finally empty brackets. So we are just initializing the queue with the courses having in degree equals 0, right? So I hope this is clear. This step is clear. Next step is we have to track the number of courses that has been completed. That's what we have to do. So if it is equivalent, then only we have to return true at the end, right? So initially we already have the this one, I think. Just give me a second. Did I miss anything here? So yeah, I'll just consider here itself instead. So yeah, let me consider here completed equals 0. So we are just we have to track number of courses that has been completed. For that sake, I'm just considering the variable completed. So the next step is we have to process courses using BFS, nothing but we'll be making use of Khan's algorithm here. So let's do it quickly. So we'll be making use of the BFS here, right? So we will process courses using the BFS, nothing but Khan's algorithm. So I'll just give here q cut length. Then what we'll do, let course equals, so here q cut pop. So we saw this one in the fourth step. We have to remove the courses from the queue. First we will take first we took 0, then we reduced the this one in degree of the 1. First we took 0, popped the 0 from the this one queue, then we reduced the this one once in degree to 0, and then we added 1 to q if you remember. Then we took 1, this example I'm speaking of, then we took 1 and then we popped 1 from the queue so that no dependencies were left. These were the 2 steps we saw. So that's what we are articulate that one in the form of code. So that's what we are articulating in the form of code here. So I'll just give here let course equals q dot pop, whatever I have given. We are just removing the course from the queue, and after removing the course from the queue, we have to mark the course as completed. So I'll just give here, let's increment the completed here. This is fine. I hope this is clear. So next, reduce in degree of all the dependent courses, right? So we are reducing in degree of all the dependent courses. So here I'll give let next of graph course. Here this will be courses. Not courses. So here we are just reducing in degree of all the dependent courses, right? So reducing in this example, we after popping this one 0 from the this one queue, we were reducing the in degree of 1, next one 1 to 0, and then finally we added that one to the queue, and then we popped the 1 also from the queue, right? So that's what we did. So I have said this one multiple times. I hope this is clear. So in this step, if no prerequisites, then we have to add it to the queue. Simple if condition here. This one will be in degree. Next, if this is equal to 0, then what we will do? We have to add that one to the queue, right? How can I articulate that one in the form of code? Adding, for adding, I'll just make use of push. Next, I'll give. This is fine. If no more prerequisites found, then we have to add to queue, right? That's what we are doing here. So we have considered next here in the for loop, next of graph, right? So I hope this is clear. So this is it for the code. Next, the final step, the last step is if all the courses are completed, then we have to return true. Otherwise, we will, if it forms a cycle, we'll be returning false. We have to return false in this case. So I'll just give here return completed. If all the courses are completed, then we have to return number of courses. So in the step 4, if you remember, the number of steps or the number of courses were 2, right? And they had mentioned number of courses in the input as 2 as well. So 2 was equivalent to 2. So we had to return true, right? In the example that we considered here when we discussed this one. So that's what we are comparing here. We have to return when all the courses are completed, we have to return true in that case. Otherwise, we have to return false here, right? So that's what we are doing here. So I'll just format this one once and let me hit the run button. So here we have in degree is not defined. So just give me a second here. So yeah, here in the line number 3, you can clearly see I have considered D small here. Let me give here D small. So yeah, let me hit the run button again. I hope this works, man. Yeah, you can clearly see the sample test cases are getting passed here. So the code works absolutely correct. So let me hit the submit button, sorry. Only the sample test cases were getting passed, right? So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is topological sorting using Khan's algorithm with BFS, right? So what would be the time complexity here? The overall time complexity would be here big O of B plus E. Right. So V is nothing but vertices, E is nothing but edges. We know this one. Where vertices we have considered as number of courses, E edges we have considered as this one prerequisites dot length of the prerequisites that we considered. So building of the graph we saw. We built a graph, right? Directed graph. Building of the graph took gives big O of E, this one big O of E time complexity. Processing nodes in the queue will be big O of V plus E. So overall time complexity would be big O of V plus E. So in this case, overall time complexity would be big O of V plus E. So what would be the space complexity then? The overall space complexity would be big O of V plus E as well. Why the space complexity here is big O of V plus E? Because graph storage, nothing but we are making use of the adjacency list, right? So in that case, the space complexity would be big O of E, only the big O of E. But in degree also we have to consider in degree array. We are considering in degree array here. Uint 16, this one. unsigned int 16-bit array we are considering here, right? So this one integer array takes big of v space complexity. So queue storage also big of v in worst case. So overall space complexity would be big of v plus e in this case. So the overall time complexity and the space complexity would be big of v plus e in this case. I hope the solution, whatever we have written, is completely clear. For now, this is it. Thanks for watching, guys.